Okay, so we're going to start off with an angle. Not to be confused with an angel. I saw what's that game where you like the first person has something they're supposed to draw. You know what I'm talking about? It's like you got some card and it tells you something you're supposed to draw. And then you draw it. And then the next person looks at what's been drawn and they try to tell what it is. And then you pass it to the next person who's supposed to draw what that person said it was. And then you see, what's it called?
I know what you're talking about.
Then at the very end, you get something that looks completely different from what it started with. You're trying to make it be the same. If you can get... But anyways, I can't remember how this one started. It started somehow, then somebody drew an angel, which is not what it's supposed to be. And then the person wrote down angle. And then the next person's drawing angles in math. Hilarious. Spelling matters. So, and this is not going to get auto-corrected, unfortunately. An angle has a vertex where two rays join. So when I look at this, that's our angle. Does everybody know what an angle is? I told you we're starting over. This is brand new math. Welcome to Trig. Okay, so we know what an angle is. Does everybody know what a ray is? What's a ray? Huh? It has one endpoint and one side continues forever. A line has continued forever on both sides. What if it doesn't continue forever on either side? That is a line segment. All right. So, where two rays join, we have an angle here. We have different ways we can name this angle. Okay, so say that we had points, say that was point A, B, and C. We could name this angle ABC. We could name it angle CBA. In this case, we could just name that angle B because B is our vertex. Now, that is not one of the preferred ways to name it because you could have examples that look like this, right, where you have A, B, C, and D. Well, now, what's angle B? Well, there's three different angle Bs. So that's why we normally don't like naming it with one letter. But you actually can on this one, but again, not recommended. Or we could put a little number or maybe a Greek letter, like alpha, in there. And we could name that angle 1. Or like I said, or it could be angle alpha, beta. One that we're going to use a lot is theta. Okay, so let me zoom in. I don't need my first theta that I draw to be ugly looking. Okay, it's like a circle with a line through it. So again, that's going to be very common. So we could also name it angle theta. So in trig, when we draw these, one of our rays is going to be fixed, which means we're going to put it in the same position every time. And that's going to be called our initial side, which we think about where it starts. So our two sides, we have an initial, which means beginning, and a terminal, which means end. Okay, so you've got your initial side and your terminal side. The other ray, we're going to move or rotate in order to create an angle, and it's going to be called the terminal side, which is where it ends. So on all of these, we imagine the positive x-axis. So think if I have an xy plane. The positive x-axis is drawn right here. This would be the negative x-axis, right? Because it's x's that are negative. This is x's that are positive. The positive x-axis is always our initial side. That's where we begin our rotation. And again, if you think about how we name quadrants, that makes sense. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. So when we're rotating, we start here and we rotate in this direction every time. Wherever this ends, our terminal side, then that is the angle that is formed. So right now, the terminal side is still in the first quadrant, so this would be my angle. Let's keep reading. An angle that has its vertex at the center of a circle is called a central angle. So imagine we had a circle, and again, think about this as the positive x-axis, the initial side. Here's our terminal side. This is called a central angle because it's an angle formed and the vertex is in the center of the circle. The arc of the circle between the two rays is called the intercepted arc. So just going to be real honest with you, I don't use that word, so you probably never hear it again. That right there, that part is called the intercepted arc. The part of the circle between our two rays. An angle is standard position if it's located on the rectangular coordinate system, so that's just the xy plane, has its vertex at the origin and its initial side on the positive x-axis. So that's kind of everything I talked about. I kind of jumped the gun. Okay, let's keep reading. The degree measure of an angle is the number of degrees in the intercepted arc of a circle centered at the vertex. The degree measure is positive if the rotation is counterclockwise and negative if the rotation is clockwise. So, again, I got my positive I got my xy coordinate plane. If this is my initial side, and say I was going to rotate in the counterclockwise direction, that would be this way, then that's called a positive rotation. If I rotated clockwise, the way the hands on a clock move, then that is a negative rotation. So let's just go over an example really quickly. What if my terminal side was here? Okay, so in the positive direction, I have rotated 90 degrees. That's a positive 90-degree rotation. But we could also talk about that as a negative rotation. If I rotated clockwise, that would put me at 90, 180, 270. And I get to the same terminal side. So that could be a negative 270-degree rotation. A 90-degree positive rotation is the same as a negative 270-degree rotation. So again, positive is counterclockwise, negative is clockwise. A quadrangle is when a terminal side of an angle in standard position is either on the x or y axis. So again, probably a term you'll never hear me use, but I guess you might need to know that. Do we know how many degrees there are in a circle? 360 degrees. So make sure we go in knowing that information. Why is there 360 degrees in a circle? Just because. Thank you. Yes. So right here. Here is a circle on the standard XY plane with some given rotations. So you'll see every degree measure they give is a positive rotation. So this is my initial side. This is where I'm beginning. And you see if I go nowhere, a 0-degree rotation puts me back right here. If I rotate right to here, that's a 30-degree rotation. I've rotated 30 degrees. This would be 45-degree rotation, 60-degree rotation. That is a 90-degree rotation. And then you see we're going in increments plus 30, plus 45, plus 60, and then plus 90. We'll use that pattern over and over again in Trig. And then from 180, we'll add 30. And then from here, we'll add 45. And then from here, we'll add 60. And so on. Now, just like we talked about before, all of these rotations that are shown are in the positive direction. We could also rotate in the negative direction. So like if I rotated here, that is a 300-degree positive rotation, or that is a negative 60-degree rotation if I'm going clockwise. Does everybody follow? I can rotate either direction. Everybody okay with that? In that last example, what we were looking at, 300 degrees and negative 60 degrees, they have the same initial side and the same terminal side. So we call those angles coterminal angles because they share their terminal side. So the angles are coterminal. So let me give some angles, and then we're going to find their coterminal angles. So say that I was looking here at a 120-degree rotation in the positive direction. Well, a 120-degree rotation would be coterminal with, how much would I have to rotate in the negative direction to get there?
240.
It's 240. So that would be a negative 240-degree rotation. So right here, this is going to be one of your major skills you're going to practice and get better with. But let me kind of tell you how I would rotate. So I rotate by 90s, and then I go however much more I need to go. So in the positive direction, I went 90, and I need to go another 30, right? Because I know this gets me 90. So then I would rotate 90, 90 is 180. So if I went 30 in this direction, that means I need to go 60 more in that direction. So 90, 90 is 180, 180 and 60 gives me that 240. And the more you do it, you'll just start memorizing these. Okay, but again, I'm not a big memorizer to start with, but you got to come up with your own system with how you're going to be able to count. You don't have to do it the way I did it, but you got to come up with something. Okay, so let's say I was here, and in the positive direction, I rotated 330 degrees. Then what would be a coterminal angle given a negative rotation? It would be a negative 30-degree rotation. I did say negative. Just make sure you put it down too. It is implied, but it's not implied like a 1 in front of a variable. Yeah, in front of an x. Okay, and then one more. I wish I'd give myself more room. Okay, what if I was here and I said this was a $450-degree positive rotation? Can I do that? Sure I can. If I go all the way around and then go another 90, that's a 450-degree rotation. Why are you shaking your head? You're the one back there talking about ratchets, and you don't put that bolt all the way around at least once. That's 360 degrees, and you go again. So what would be a coterminal angle with 450 degrees? You could go with 90. But again, that would also be a positive coterminal angle. What if I wanted a negative coterminal angle? What would that be? Well, you don't have to go that far. Negative 90, negative 180, negative 270 would be coterminal. But I like where you were going. You were doing what?
360 plus.
Yeah, 360 plus another 270. That would give us 530, 540, 630. Hold on, 630. So if I went, let me do a different color. because that's going to clear this up a whole lot, a different color. If I went here to negative 360 and then another 270, I could have negative 600 and, what was it? Yeah, I knew that. Negative 630 degrees. All of those would be coterminal angles because they have the same initial side and the same terminal side. So that's an interesting point. So if I pick any angle, how many different coterminal angles are there? An infinite amount, because I could keep doing rotations. Now that's not super relevant, but it is cool that, hey, I could just come up with a new angle measure by going around another 360. To find coterminal angles, we can add or subtract 360 to any angle, right? We could rotate in any direction, yeah. And since we can keep adding or subtracting 360, we really have infinitely many coterminal angles. We already talked about that. Find two positive and two negative coterminal angles too. So first is 45 degrees. So now we can find the coterminal angles without actually having to draw them, because we know we're just going another 360 degrees around in either direction. So if I had a 45-degree rotation, two coterminal angles to that would be, I could add 360 and I would get a 405-degree rotation. I could add 360 again and I would have a 765-degree rotation. Yes, now we have to find two negative coterminal angles. So I would go back to this 45 degree, and what if I rotated the other direction 360 degrees? So that would be subtracting 360. So 45 minus 360, that would give negative 315 degrees. And then if I subtracted 360 again, that would be negative 675 degrees. And again, we could keep adding and subtracting 360 to find more coterminal angles. Okay, the next one is a negative 50-degree rotation. So I'm going to find my positive ones first. So I would add 360 to that, and I would get 310 degrees. I could add another 360, and that would give me 670 degrees. Or I could go in the other direction. I could subtract 360, so I go back to the negative 50. I subtract 360, that's going to give me negative 410 degrees. And if I subtract 360 again, that's going to be negative 770 degrees. And all these would be called coterminal angles. Okay, so now I'm given two angles, and I want to know, are these coterminal with each other? Okay, so if I want to know if these are coterminal or not, I need to know, do they differ by some measure of 360? So what I would do is I start with the positive angle. I would start with 261. And then I would subtract 360 from it. When I do that, I get negative 99. Well, that's not quite to negative 807, so I could subtract 360 again and again, and then that puts me at negative 819, which is not matching up with negative 807. So once I finally rotate past it and I don't match it, then I know that these are not coterminal. Everybody follow how I did that? Just adding and subtracting 360. Now on the B part, I would start with 205, and I would subtract 360 to get negative 155, and I would subtract 360 to get negative 515. So because I got the same measurement by adding and subtracting 360, then I know that these are coterminal. Okay, so now we're going to be given angles, and we want to know what quadrant does the terminal side lie in. So the first one gives an example of 200 degrees. We want to know what quadrant is 200 degrees in, a 200-degree rotation. So I know that this is my initial side. And so again, I go by 90s. So I would go 90, 180. I know that 270 is too much. So between 180 and 270 puts me in this quadrant, which is the third quadrant. So I would know that this is in quadrant 3. So again, there's probably different ways you could do these. I'm just showing you the way that my brain thinks about them. Okay, so if I had to find 40 degrees, well, 40 degrees is between 0 and 90. So I know that a 40-degree rotation puts me in the first quadrant. Now, if I was doing 750, again, there's a couple ways you could do it. So you could just rotate it. You could go, this is 90, 180, 270, 360, 450, 540, 630, 720, 810. So because we're between 720 and 810, that's going to put me in the first quadrant. Or the way that I would do it, I would get that down to a smaller angle to start with. So 750, I know if I do 2 full revolutions, that's 720. So then I would do 750 minus 720, which is 30. And 30 is in the first quadrant. So that means 750 is in the first quadrant. Okay, that's the way I think about them. Negative 280. So you could go in the opposite direction, negative 90, negative 180, negative 270, negative 360. So again, that's somewhere between those two. So it's also in the first quadrant. Or you could say negative 280. I could just add 360 to that. Negative 280 plus 360 is 80. And 80 is in the first quadrant because it's between 0 and 90. So again, just different ways you could think about it to get to the same answer. And the last one, negative 500 degrees. So I would add 360, and that would put me at negative 240. And I know that negative 240 is in this quadrant. So that would be in the second. You could have added 360 again to negative 240 to get 120. Again, multiple ways you could go about getting these answers. Okay, these tell me to find the measure in degrees of the least positive angle. So it has to be positive, but we want the smallest possible positive angle that is coterminal with the given angle. So when I start at 540, 540 is already positive, but it could be too positive, right? Because there could be an even smaller positive coterminal angle. So I would go 540 minus 360 to get 180. Now, if I subtracted 360 again, what would happen? I would get a negative 180, so it became negative. So I'm not looking for a negative coterminal angle. I want the smallest positive coterminal angle. So that would be 180 degrees. Now, in the next example, we're going the other direction. We start with negative 400, and now I want to make it positive. So I'm going to add 360 to it until I get it to be positive. So the first time I add 360, I get negative 40, so it's still not positive. So I would add 360 again. That would get me to 320 degrees. So 320 would be the smallest positive angle that is coterminal. And then the last one, I've got negative 1100. So again, I would add 360. That gets me to negative 740. I would add 360. That gets me to negative 380. I would add 360. That gets me to negative 20. And then I would add 360, which gets me to 340 degrees. And so that's the smallest positive coterminal angle. Could you have fractions of degrees? You could. So each degree is actually divided into 60 minutes. And each minute is divided into 60 seconds. So kind of like how we do with time. Each hour has 60 minutes, and each minute has 60 seconds. So same idea. Terrible. Why in the world 60? Okay. An angle could be called 42 degrees, 13 minutes, and 26 seconds. That's what those little tick marks mean. That's degrees, that's minutes, that's seconds. Since we are comfortable with decimals, instead of seeing 42 degrees, 13 minutes, and 26 seconds, our calculators would give us 42.224 degrees. And that's what we see most often. So we're going to do some examples of converting. So the first one, if I've got 42 degrees, 12 minutes, and 45 seconds, then the 42 is like our whole number. So we've got a whole 42 degrees. Now, if you've got 12 minutes, think about how many parts of an hour that is. 12 over 60. Yes. So maybe an easy one to think about is 15 minutes. 15 minutes is what part of an hour? It's quarter of an hour, right? 1/4. So how do we get that 1/4, quarter of an hour? We put the 15 over 60. 15 over 60 reduces to be a quarter. So same idea here. We've got 12 minutes. So I would put that 12 minutes over 60. And that would give us 12 over 60, which is a fifth of an hour. So that would reduce, but we're not worried about reducing right now. And then the last part is seconds. There are 45 seconds. So we would put that 45 over 3,600 because it'd be 60 minutes times the 60 seconds, which would be 3,600. So again, I know that y'all would probably put those in your calculator instead of finding a common denominator, right? But if I added all those up, that would give me, I don't want to do it in my calculator, 42.2125. Okay, 42.2125. Any questions about how we do that, converting from degrees to minutes? Okay, and I'm going to do those other two in just a second. I'm going to come back to them. Now let me show you how you go in the other direction. So if I had 42.457 degrees and I wanted to make that into minutes and seconds. Okay, so again, let's go back to an hour really quickly. So what if I had 1.5 hours? We know that is what? That's 1 hour, how many minutes? 30 minutes. Do you know how to get from 0.5 to 30? Think about it. Multiply the decimal part by 60. And that will give us how many minutes there were left over. Same idea here with the 42.457. So we know this is 42 total degrees. Now we take the decimal part, which is 0.457, and we would multiply that by 60. When I do, I get 27 whole minutes, and I've got 0.42 minutes left over. So what do you think that part is? That's our seconds. So I'm going to take that leftover 0.42, and I'm going to multiply that by 60, which gives me 25.2 seconds. Yes. So again, it's hard for me to do it. I would do it on my calculator, follow on my calculator. So I've got 42.457 degrees. The 42 is the whole number part. So I know it's 42 whole degrees. So it's kind of like I take that part off. And I'm left with 0.457, just the decimal part. I take the decimal part and multiply it by 60. When I do, I get 27.42. So the 27 is the whole number part. So that means I have 27 whole minutes. Then I take the 0.42 and I multiply that part by 60 because that'll give me the seconds part. So I take 0.42 times 60 and that gives me 25.2 seconds. Any questions there on converting from one to the other?